Vector functions are used to represent curves and trajectories. But before being able to do that, we need to take a closer look at them. This is calculus with Python with the introduction of vector functions, curves and trajectories. A vector function is a function that associates n-dimensional vectors to real numbers in some domain of the line, usually an interval. The components f of t, g of t and h of t of these vectors are the component functions. And t is the parameter, often time. Frequently we are interested in 2- or 3-dimensional vector functions to represent plane or spatial curves. Not all vector functions describe what we conceive as a curve. We often want our curves and trajectories to be continuous. To define this mathematically, we need to take a look at limits. And the limit of the vector function, r of t, is the vector obtained by taking the limit of each of the components of r. A function is continuous at some point, a, of its domain, if the value of the function is equal to the limit of the function when t tends to a. This ensures that there aren't sudden jumps in the value of the components of the function. Here we have some Python code plotting an ellipse. You can access the page with the code and the links in the description, and change them to plot your own functions. Each vector function describes not only a shape, but also the way, or the speed, a trajectory is being traveled over. Python can be used to animate a point moving in accordance to this vector function. The next code does that. We can also plot a curve in space. In this case the code is plotting an elliptical spiral, but you could run your own functions. Last but not least, you can change the velocity without changing the shape of the curve, by replacing the variable t with some expression f of t given by some function f, whose image is equal to the domain of the original vector function. Try the codes and see if you can reparameterize a curve. Thank you so much for stopping by. If you like the content, please give us the thumbs up, check out our codes in the description links, and share this video with your calculus interested mates.